Hello. Yeah, welcome to this presentation on risk and capital budgeting. So I want to give you a conceptual overview of the chapter, just an introduction to this concept. And then maybe later on, we will try to work through some examples or problems involving risk and capital budgeting. Now, my focus uh, uh, on this concept is going to be to ideally show you why risk is very important and how we go about in analyzing or in measuring risk. And then, of course, in the second part of my presentation is going to be on capital budgeting, where now we pick up the how we measure risk and then how we apply that measurement in capital budgeting. So there's in the previous chapters, what you have seen is where we have been able to complete or address things to do with valuation. So if you remember, we have covered something on valuation. Uh, we also have covered something on cost of capital, just trying to give you a broad overview on what we have done so that you can see where we are going. We have also covered something on the methods or techniques when it comes to capital budgeting. So we have covered capital budgeting techniques. Again, if you remember, things to do with, for example, uh, the net present value, the internal rate of return, the modified internal rate of return, or the payback method. And this just continues our discussion, because remember, in all these issues, for example, in valuation, and if I use bonds as an example, we said the way we value bonds is we determine the cash flow, and then what we do is to discount those cash flows, and we discount the cash flows using a particular percentage, which we just call the discount rate. And then in our following chapters, then you remember this discount rate is basically the cost of capital. So if you think about it, that discount ideally is the cost of capital. But in the cost of capital, we went further because we did look at the weighted average cost of capital. So in our focus in this chapter, remember that weighted average cost of capital, or the normal discount rate, if you think about it, it represents a particular risk. So in the focus of this chapter is to look at how we measure risk, how we see that 12% or 10% as being the cost of capital, and then what can you do if the risk inherent in a particular project or in a particular investment is so high than what you expected. If that's the case, should you then modify the risk, and therefore you're basically modifying the cost of capital, or that discounting rate that we're referring in this case. So we shall look at this as we go. But again, this is just a conceptual overview of the chapter to show you where we are heading. Now, think about this, and I just have a slide here showing, uh, and again, I'm going to showing the three types of investment or a project. So there is a project A, there's a project B, and a project C. And we are saying, if we are talking about risk, and again, but in finance, the truth is always everyone wants to avoid risk. So we are always risk averse. So if we know what the risk is going to be, then you could make decisions on whether to invest in A or B. Again, you want to avoid as risk as possible. And if you're going to take up a particular investment and you know that the risk is so high, you'll then expect expect that that project has to pay you so high to compensate for the extra risk that is inherent in that particular project. So how do we measure risk? So ideally we have these three projects, and if you look at it, project A and B and C. And the question we always ask is, how do we measure risk? What can we look at in trying to understand what the level of risk is? So again, we borrow this from mathematics. And you remember I told you earlier on, we're going to borrow some of these things from math, some of these concepts. And here's an example where we basically borrow some of the math concepts and we try to use them in finance. So to understand risk, what we do is we look at some mathematical concepts. So we look at, for example, these are things you have done in your previous class or any other class, so you understand this. So we use the standard deviation. So we use this concept of standard deviation to help us understand the level or the nature of risk. So if you're looking at historical numbers or historical data of some returns, so here we are focusing on returns on a particular project. So if you look at the returns, you could use those returns and build up or determine the risk level in those particular returns. And if you look at A, B, and C, I will ask you, for example, in which of those investment projects do you see that the risk is high? And I'm sure some of you will tell me that the risk is high when it comes to investment C, than investment B, than investment A. So if you have to choose two investment or just one investment here, again, if you're risk averse, you want to avoid risk, and these are the return distribution showing all the returns for particular investments, and I'm sure some of you are going to tell me you'll choose investment A because it seems that's the one that has the lowest risk. So you're going to choose A and not C and not B. And the reason is because, again, think about it. We measure the variation in a distribution, right? So if you look at normal distributions and you look at the variation, you'll find that the variation in C is so high. In other words, the returns in investment C, those returns are so much dispersed. There's a higher dispersion in terms of those returns than there is in investment A, because investment A returns are closely tied together. So in terms of variation, returns for project A are closely, they're close to each other than it is for investment C. And that's why investment C, because the returns are so much dispersed, there's a high variation in those returns, the likelihood of you again achieving a particular return in C is so remote, than when it comes to A, because in A, they're all closely tied, or they're close to each other. Therefore, the risk level in A or in A is lower than it is C. So we use the standard deviation concept to try to measure. It's just one way of looking at risk and one way of giving you an idea which investment has a lower risk than others. But again, we go further than this, and you're going to see later on when we're trying to cover, or when you're trying to measure exactly, the nature of the risk in a particular investment, we try to look at something else. And what you're going to see later on will be, yes, we know how to compute the standard deviation, and we know how to compute the expected value. Again, this is basically just computing the mean. We know how to compute the mean, and therefore the expected value will be the mean times the related or associated probabilities. The standard deviation, again, mathematically, if you're to compute the standard deviation of a data set, what you'll do, again, you're going to determine the mean first of all. Once you determine the mean, and then you're going to determine the deviations from each outcome. So the D represents the outcome. So if you have 3 outcomes or 4 outcomes, then what you'll do is you'll take outcome for the outcome 1, and then you subtract the expected value or the mean, and this gives you the deviation. And then you'll do the same thing for outcome 2, and again you subtract the mean for that sample, and then again for 3 you'll do the same thing, and this just gives you the deviation from the mean, where again the D bar represents the mean. So each is a deviation from the mean, and what we have done is you'll always try now to square. So once you determine the mean, so first of all you determine what the mean is, you find the mean, and then what you do is you find the deviations from the mean for each outcome, and then what you do is you're going to square those deviations. And the reason why we square the deviations is to get the absolute value. Again, this is just something you've covered in your math class before. And then we multiply this with its related probability, right, times P, which is the probability associated with outcome D1, and the same thing for D2. So in this case, you'll multiply this with its related probability, right? And then you're going to sum everything together. So this is what you had. So what you do is you're going to sum the values, and this will be the value, the summations of all your square deviations times its related probabilities, and you're going to get a value. Again, this will be now what we call the D minus D bar, again times, of course, its probability. So this is basically the end result, and then what you do, you'll find the square root of the sum of the square deviation times their related probabilities. So this is basically what you get here, and then this gives you what the standard deviation is. So this is the standard deviation. Again, if you're looking at two projects or 3 projects, then you can have the standard deviation for project 1, project 2, and project 3. And then if you have to compare and determine where the risk level is in those 3 projects, then of course you can look at the standard deviation. But again, if you look at it, you'll find there's a case where you have a higher standard deviation in one project than in the other, and so on and so on. But again, you cannot just use the standard deviation as the sole conclusion that project A is risky than project B, because in this case you'll find the mean for project A is not the same as the mean for project 2 or project 3. So in that case, then you have to go a step further, and therefore we use the coefficient of variation concept to really understand the nature of the risk inherent in that particular project. And then we can now, in this case, we can say we're going to compare apples to apples. So you can now compare project A to project B or to project C, because again, in this case, you're using the coefficient of variation. To compute the coefficient of variation, what you do, you'll take your standard deviation, divide this with the mean, and that is the D bar. And by this, it basically tells you, again, if you think about it, if you're taking the square deviation, divide this with the mean, so it's basically telling you per every one mean, what is the nature of the risk, because we're using the square deviation to determine the mean. So in this case, then it's telling you for every one uh, one mean, for example, then what is the number of the risk inherent in terms of the square deviation and so on. So in this case, then you can compare apples to apples, and that would be a true measure of risk in a particular investment or project. And here is just another example, just to show you, again, from what we learned before. If you're looking at those 3, project A, B, and C, again, in this example, you've been given what the mean is, and we've been also been given what the standard deviation is. For example, in this case, you've been given your mean is 600 and you've been given the standard deviation is 20. For this particular project, you've been given your mean is 6,000 and you've been given the standard deviation is 190. In this one, you've been told the mean is 600 and the standard deviation is 300. No, this should be 600. So this is 600. So your standard mean is 600 and standard deviation is 190. And this example is also 600 and also 20. So in this example, your mean is the same across the board in all the three projects. The only difference is the standard deviation. So in this case, you'll find you have a lower standard deviation, and therefore you can say the risk level here it's lower. You have a low risk here. Here, you basically have a higher risk because you're talking about a standard deviation of 300 and here a standard deviation of 190. So you have a moderate. So you can say maybe here is moderate. Here, your risk level is low. And here you can say the risk level is high. Again, if you're just trying to look at the standard deviation as a measure of risk. So that's how you'll try to use the numbers to make sense. But again, the truth is you have to go beyond just the standard deviation because it's not enough. So you have to look at the coefficient of variation to basically tell you. So again, in finance, we say the larger the standard deviation means the greater the risk. And that's why you have a high risk here because you're talking about a 300 standard deviation and here you have 190 and 120. And therefore the lower this standard deviation, the lower the risk. So you have a low risk here and you have a high risk here. Again, if you use the standard deviation as a judgment tool. Again, as I said before, you can go beyond just the standard deviation, and the reason why you want to go is to compare apples to apples. Therefore, in this example is even though you have two data sets, we have a normal distribution of project A returns and project B returns. In this example, you can be told that A has a 6,000 mean and B has a 600 mean, and you could see then A has a standard deviation of 600 and B has a standard deviation of 190. In this case, of course, there's a lower risk in A than it is in B, but that's not true because remember, if you think about it, the distributions for A seems to be closely together than it is the distributions for B. But that's not the case. It shows you then B has a lower risk than of course A. But if you think about it, it should be the other way because you're looking at the variation in that particular distributions. So the direct comparison of standard deviation is not helpful if your expected values of investment differ. So if the expected values of the investment, if the mean values differ, then you want to go further and use a different measure to try to understand risk in that particular investment or project. So the standard deviation of 600, for example, from the chart here, with the expected value of 6,000, indicates a less risk than the standard deviation of 190 with expected value of 600. So in that case, again, you want to go further, and therefore, again, the coefficient of variation is what you're going to look at by taking again the standard deviation and divide this with the mean, and this will give you the risk per each return of mean. So per each return of mean, what is the risk level in that particular project. So we use the coefficient of variation to do so. So this helps us just to understand further the level or the nature of the risk. So the size, difficulty of the distributions, we can eliminate that size, challenges by basically introducing the coefficient of variation. And you could do that. Again, if you do that, you'll find that gives you a true measure of what the level of risk is in that particular project. So I'm going to stop here and just come back next to continue, where again now we know what risk is, we know how we measure risk, because again from a mathematical point of view we're going to look at the data and compute a standard deviation and compute of course coefficient of variation. We're going to see different later on that hey, there are also other tools that we can use to measure risk, but it's just an introductory perspective on how we measure, or just to give you an idea of what risk is and how we go about in trying to measure this risk. So keep that in mind, and we're going to jump to something else different, because in the next part of this presentation is going to capture the capital budgeting perspective, which we have done part of it in our previous chapter. But again, the point is, if you know what the risk is, then how do you use that particular knowledge in advancing your budgeting decisions? But you have to remember, even though you're looking at project A, and B, they just don't have the same risk. So you're going to have some projects will have more risk than others. And the question is, if that's the case, then what are you going to do? Again, ideally speaking, what you're going to do, you're going to adjust the the level of the risk to compensate. So if the risk is high, you're going to increase your discount rate. If the risk is low for that particular investment or project, then you're going to lower the discount rate, and so on and so on. So look forward for the second part of that presentation, where we're going to advance this to the next level.